Well, good morning. Good morning. You're welcome to today's lecture, still on the course PDT 152, Basic Dispensing Theory 1. Today, will be a kind of revision and round of what we've been doing in this course, because this is my last contact with you before your examination. So, as you pointed out that I should look into some aspect of this, what is it called? Suppository evaluation. That is disintegration / dissolution testing. Of course, disintegration is no longer a new term to you, right? Neither is dissolution a new term. You come across it in tablet and capsule, right? Good. And I say that rate limiting step in drug pharmacokinetic is what? The rate limiting step in drug pharmacokinetic is what? Mixing. That one is drug formulation. Formulation of drug. We are taught pharmacokinetics. Have you done it in AEM? And I say, so what is pharmacokinetic? Is it how you? Yeah. Okay. So I now ask the pharmacokinetic of a drug or a medicine formulation in the system. What is the rate limiting step? It's not true. Good morning. Dissolution, especially tablet, capsule, and what have you. Okay. Now. But that of suppository is what? Suppository. It's not medicine. It's not dissolution. We discussed it in this class. Didn't we talk about the partitioning? Yeah? Did we discuss the partitioning of the drug, suppository, and the? We talk about it now, right? Yes. When we talk about the partition was coefficient, right? Right? Good. Is that partitioning that is what? The rate limiting step, not dissolution or what is it called again? What have you? Disintegration, blah blah blah. Now let's cut. So now let's look at this aspect that we pointed out. The dissolution. What is it called? Disintegration / dissolution. What? Testing. Now, of course, now you need to test. Does it disintegrate? For those that disintegrate when they come in contact with what? Rectal what? Fluid. Am I communicating? And so if it disintegrates, what happens to the active ingredient? Is there any dissolution? So now in an effort to control the variation in the mass / medium interface, various means have been employed, including wire mesh baskets or membrane to separate sample chamber from what? Reservoir. Remember when we are doing something, I told you that in the disintegration test, they use a basket, small basket, right? Put it in a tablet, suspend it in a liquid that may they use water anyway, but it's a simulation. You water and down, then see how fast it will do what? Disintegrate. Am I communicating here? Now, it is the same process. It's the same what? Because this one now is in contact with what? Rectal fluid. It's not what? Melted. It's not a body temperature issue. It's not a rectal temperature issue. Instead, it's rectal what? Fluid. So it's the same what? The same way tablet goes to the gastric fluid, and the same way when it comes in contact with the rectal fluid, it's also what? It integrates. So all these things are just the process. When the sample you want to test, you seal it in a dialysis tube or natural membrane. Then You know, the different, we have baskets. Baskets. We have the one, you sell it in a what? In what? What? There, good. The dialysis what? Dialysis what? Different methods has been what? Studied to take a decision on the one that is, but come what may, the basket own is still the what? Is still the what? It still stands. Even using flow cells. Although flow cells have also been used in holding the sample in what? Peace, blah, blah, blah. But the point there is that it still boils down to the what? It's integration, but most of the, except when it comes to pastries, nasal bougies. I think we mentioned nasal bougies that come in contact with the nasal bougies. What else? Unless urethral suppository, it's okay. Then apart from all the other suppositories have no business with this. Am I communicating? They have no business with the focus is mainly to the what? Mainly to the what? Rectal what? Temperature. But still, why it's good to study this is that you never know the one you come in contact with, but mainly this just few of them has to do with what? Fluid. Majority has to do with what? With what? The body what? Temperature. Am I communicating? Good. Now, there's nothing so serious here, it's just the same. But the point I want you to take home with is the issue of what? Is issue of what? Using what? A mesh what? Basket. That is the key point there. Mesh basket with the what? With the what? But when I say basket, I don't mean basket. If you see it, will look at the whole, just small. Okay. Have you come in contact? You are this thing. What's it called? You are generator. You see your generator. That if you go to where they put fuel, something of that nature, the temperature is suspended in it. They will now drop it in the fluid and watch with small agitation and watch how long it will take to do what. That's what I mean by the basket in question. Is it clear? Yeah. You know that is just a basket. Yes, a basket. The basic thing is that the sample is using a mesh basket. The sample is dropped in mesh basket and suspended in the fluid in question. The fluid they normally use there is water in the testing, but just mainly water anyway. Then they will now apply small agitation. You know what I mean by small agitation. You know that the stomach walls give some a bit agitation to it for you to do what, be able to do what, disintegrate. Just with that small agitation, they now watch how long it will take for it to what, disintegrate. Is it clear? Now, what else are we supposed to look at? What else? Let's look at it before we see any other topic we can do something on before we call it a day. What happened to in-package molding? Where is it? So tell me what is it you don't understand there? Okay, hello, see what it means. Here if you are doing hand molding, pour or whatever, pour molding, everything is manual. But that one is purely for what? Automated packaging. What it means is that the machine is doing everything. It's not you. that is doing it. Am I correct? That is the summary of, that is the basic understanding of that in idea. It's automated. It's not the one you do with your hand. You go and start looking for putting it in mold. Everything the thing is molded. It will be sent to where that aloe or any other material they want to package it. As the thing is molded, it will be ejected and enter the cell. The thing, it will just seal it up. Yeah, that is aluminium. That's why I call it aloe now. Aluminium is Al. It's aluminium foil. I thought I didn't bother myself talking about it because we did it. So we explained it. So I thought maybe if you see L, you understand that it's Al. Although some people write it aloe, meaning aluminium as an aluminium foil, but that Al there is aluminium. So the packaging, they can use the packaging, the material which is aluminium foil to do what? Achieve that. Not only aluminium, they can also use plastic and other what? Material. The main thing is to achieve your what? Purpose. Alright, what else? Where else do we look into? If there's no other, I wish you well and go and rest.
It's that calculation.
No, I will not do calculation.
Good morning.
Good morning. We'll do it in when we do it in, there's a topic. Good morning. There's a topic in FAMCAC we call density, specific gravity, specific volume, and displacement volume. That's where we do it. There's a topic. I think that should be the 8th topic in FAMCAC. Density, specific gravity, specific volume, and where?
You just keep it and say
that should be on the after what? Polymorphism. Okay. Okay. Are we together? Someone said I should talk about this polymorphism in what is it called? Cocoa butter. All right, let's look into it. Of course, we've described polymorphism as existing in what? Different crystalline what? Forms, right? Good. Now, we say that why do polymorphism occur in cocoa butter? Why? Because of what? We discussed it in this class. The reason why polymorphism is observed in what? Is observed in what? Cocoa butter. We say it's because of the what? High proportion of what? Unsaturated triglycerides. That's why polymorphism. That is why polymorphism is observed in what? Cocoa butter. Because cocoa butter has a high proportion of what? Unsaturated what? Triglycerides. So the formation of these various forms of cocoa butter depends on the degree of heating. It depends on 1, degree of what? Heating. 2, cooling process. And 3, condition during the what? Processing. Am I communicating? There are 3 factors that determine the formation of these various what? Cocoa what? Forms. 1 is what? The degree of what? Heating. 2 is what? The cooling process. And 3 is what? Condition. And each of these cocoa butter forms, they have what? Different what? Melting points. That's where the issue lies now. Hello? Have you not seen where the issue lies? That each of these, they have different what? Melting points and different what? Drug release what? Rates. You know there are 2 things here now. And that will help you out actually to get the best of the what? The, what is it called? The base you are using. Does it melt? What is the melting point of that base? Now, how does that base release the what? The active what? Ingredient. So, but this cocoa butter, different forms. They have different melting points and different drug release rates. Which means that if the thing can mistakenly, the thing can transform to a form that will have a very poor, low, or very high melting point, and it will affect your work. It's not true. That's why this polymorphism poses a what problem. You may start with a form that you have wonderful. We say that cocoa butter has around 35 to 36 degrees Celsius melting point, right? You may start with that one, wonderful. But before you say Jack Robinson, it has transformed to something else that will start giving you something, a different method. What is smelling like this? Hey. It start giving you a different melting point or drug release pattern rate that will not give you what you are doing, looking for. That's the problem. Now, let's look at these different forms that exist. There are 4 crystalline forms that of cocoa butter. There are four of them. We have alpha, beta prime, and gamma form. We have alpha, beta prime, and gamma. Are we together? How are you? Different, that's the forms of what? Cocoa butter. I said there are 4 forms. We have beta, beta prime, and gamma. Are we together? We are distracted. What is it? Please, let's. The entropy in this class is very high. Please, let's bring it down. Now, I said that we have 4 crystalline states of what? Cocoa butter. So, and they have different melting points. And the drug release rates. That's why this polymorphism is not a good thing. It poses a problem. Because you may start with one and end up with another one. Maybe they process this, they think that it's one. But by the time it gets to the company that will use it, that is another one. So it's a problem. So now, let's study them now. The alpha form melts at what? 24 degrees Celsius. Is obtained by what? Suddenly cooling method. Cooling melted cocoa butter to what? To what? I said by suddenly. You produce it by what? Suddenly cooling what? Melted cocoa butter to what? 0 degrees. So if you have a melted cocoa butter, you suddenly cool it to what? 0 degrees Celsius. You obtain the what? Alpha form. The melting point is what? 24 degrees Celsius. Are we together? Then for the beta form, the melting point of the beta form lies between 28 and what? 31 degrees Celsius. I said that the melting point of the beta form lies between what? 28 and 31 what? Degrees Celsius. And how is it produced? It's manufactured by crystallization process. What happens is that within the range of 18 to 23 degrees Celsius, it crystallizes out of liquefied cocoa butter that is subjected or exposed to what? The temperature range of what? 18 to what? 20 degrees Celsius. You know what is crystallization, right? So it crystallizes out from where? Liquefied what? Cocoa what? Butter. At the temperature range of what? 18 degrees to what? To what? 23 degrees what? Celsius. Now, what of the beta prime? What is melting point of beta prime? 34 to, and is that between 34 and 35 degrees what? Celsius. Are we together? Are we together? Then, but one thing with this, that it changes, it can slowly go back to what? The stable beta what? Form. It can slowly go back to the what? The stable what? Beta what? Form. Did we mention volume contraction here? Someone say, Someone say, Someone just denied me now. And said, What we discussed? We said it not once, not twice. Even yesterday, we also discussed it at what? Details. When we were talking about overfilling. We talk about it, right? We say that does cocoa butter does it have a low volume of contraction, or does it have a low or high volume of contraction? Cocoa butter. Does it have a low or high volume of contraction? Cocoa butter.
It's low.
Is what? Is low, right? So what is the implication? What is the implication of having a low volume of contraction? What is the implication? Good. So what is the final implication now? What are you supposed to do?
Apply lubricant.
Good. So that means it requires what? Some questions may not be direct. Which of these require what? Lubricant. Before you answer it, you should need to know whether they can stick on the wall or whether they have volume of contraction, and these are things you should know. We've discussed it at length in this class. So what of the gamma form? The melting point is what? 18 what? Degree what? Celsius. How is it obtained? Whenever is talking, nobody is talking. Someone should tell us how it's obtained. By what?
Pouring a cocoa butter before it solidifies.
Okay.
Into a container which is cooled at deep freezer temperature.
Good. So before a cocoa butter in liquid form that means near to its solidification point, right?
Yes.
Right? Near to its what? Solidification point. You do what? You pour it where?
Into a container.
Which is now immediately what? Cooled in a deep freezer. It didn't say just refrigerator. It's specific. Deep freezer temperature. Am I getting? That's how you obtain what? The gamma form. Now, what is the implication of these forms? Now, which one now? What do we know? Okay, by the time we get down, you begin to appreciate how to now handle what? Cocoa butter what? Suppository. Now, let's continue. Let's continue. Now, if you look at, if you go down now, you see that, you see now, if you go down, you see cocoa butter, that you see, if cocoa butter is heated at what? Heated at what? What happens? It will go to where? So which of these is more stable? Among all these, which one is the most stable? Better, right? What is the implication? No. What's the implication? That means, if you are asked now to use cocoa butter now, will you go for alpha form, beta form, or gamma form? Because you don't want the one to be changing anyhow, right? That's not the best. That was not romantic. And let's continue. All right, now. Okay, now. Look at this arrow. I noticed that some of you got confused there. Which direction is it going to? Cooling. There are two things here: cooling and heating. So heating goes to where? Huh? Okay. Cocoa butter is a solid on this one now. Cocoa butter is there. Now, if you heat it, this thing now shows something. No, just watch out. That the cocoa butter in the circle here is just cocoa butter. You don't know which is which, right? Now, but if you heat it and slowly cool at 36 degrees, it will form a what? With normal what? With normal what? Now, if you heat it on rapid cooling, it forms unstable one, right? Which melts at what? And that unstable one is what? The gamma, right? Now, the other one now, the other side now is the unstable one again is what? Alpha. That melts at what? 20 degrees. So, unstable forms return to the what? Stable forms. Listen carefully. Unstable forms return to the what? Stable forms after days and may not set at what? Room temperature. Or if set by cooling, they may remelt in warm what? Condition. So the unstable one, will you see? The unstable ones, you don't use them. Am I committing? You don't do what? Use them. Am I committing? Because they keep changing. They will melt. If you allow them, after a few days, they do what? They go back, and you think that they have actually gone back to before it was going on. They will, any warm condition, they will change again. So this is what you keep observing. So the point is that means that there should be specification. Remember when we discussed suppository-based specifications, the components, the nature. That the first point we discussed in the specification. These are things that we specify. Let's say you want to go and buy it now. These are the things that we will specify, whether it's what? Alpha, beta, or what? Gamma. So you go for the what? The beta. Even the beta prime still go back to what? The stable one. Beta. Two of us. Yes. So the one you go for is what? The beta what? Are we together? Now, let us now look at what these issues, these things that is observed with theobroma, cocoa butter, suppository. Number one is what? Adherence to what? Mold. We have discussed it since, so that's why I told you just read up this symbol. Let just do it. It's a revision class, okay? Everything goes in the chapter. Through of us. Let's just talk about it. That's why I didn't want to waste our time in the normal side, because I know that I mentioned this several times. We also mentioned it this morning, that what? Adherence to the what? Mold. That's one problem with what? Cocoa butter what? Suppose it's now. Cocoa butter does not contract what? Sufficiently on cooling to loosen the suppository in the what? Mold. It doesn't contract what? Sufficiently. Sticking. How do we overcome this problem? Good. So sticking may be overcome by what? Adequate what? Lubrication. Haven't you been talking about this since? But let's just do it for blessing. She asked for it. Now, another point there is that softening point is too low for hot climate. Remember the test for what? Softening time. Remember that? Test for what? Evaluation of what? Suppository. Is softening time not there? Yes. So this suppository, this cocoa butter has issue with what? Softening point. The softening point is too low in hot what? Climate. Any hot climate, it will do what? Soften. It cannot resist hot water. So that means what it means that make sure that you remember when someone asked me, can he stay in a room temperature? So I told that depends on the what? The base you are using. So if the base of the suppository you are having in your pharmacy is cocoa butter. You don't need anymore to tell you, oh boy, here a fridge. Don't even keep it at room temperature. Put it where? Fridge. You don't need a prophet to tell you that. Have you seen the importance of this thing we are doing? What? Studying. Even though most people may not tell you active ingredient days. Okay. So maybe I don't know. I don't have any in my possession. Now let me know whether they indicated the base they used. But in case you are able to discover the base, you should be able, this information will help you to know exactly where to do what, keep it. Is it the one that can withstand even room temperature? Are we together? Good. So these things are important. Now, how do we now raise the softening point? To raise the softening point, white beeswax may be added to theobroma oil suppository, intended for use in tropical and subtropical countries. Is Nigeria a tropical country?
Yes.
Are you sure? Mm-hmm. So if you want to use it in tropical and subtropical countries, you know that if you go to Iceland, if you go to some part of the world that even say snow is everywhere, do you need? I don't know if I can get it now. Yeah, but here, if they use theobroma oil in supposed to be, please, don't even need your boss to tell you. Carry it and get it. Hey, don't worry. You know what you are doing. Go and do what? Keep it in free. Because if room temperature may even cause issue to it. But doing manufacturing, doing production or formulation, these things are maybe you see yourself in manufacturing outlet tomorrow. These things are what the ideas you can bring to the table that will even though nobody is indispensable, but at the same time, that's how you sell yourself. That's how you'll be productive in where you're working. You become somehow what indispensable. If they think of who they will sack, they won't even think of you. Is that not a kudos? So that's what I'm making now. So there, maybe doing manufacturing now, you cannot do what? Incorporate bees wax. If you incorporate it in the theobroma oil suppository, it will do what? Raise the what? Softening what? Point. It will raise the what? Softening point. Now, another issue is that the melting point of theobroma suppository base is that presence of soluble ingredients affected. So presence of soluble ingredient melts. So the melting point of suppository base of theobroma suppository base is reduced by what?
Soluble ingredients. What
it means is that during formulation, maybe that the other ingredients there are soluble. It will affect it. It will reduce the what? Melting point. So example of such ingredient. Hey, there's a one. Even when I was in school, it formed part of our exam. Which of the following active ingredients cannot be formulated using theobroma oil? Coral hydrates. Very, very important. We don't even try it. It will mess up the whole thing for you. Now let's look at it now. Phenols and what? Chloral hydrates. Phenols and what? Chloral hydrates have a tendency to lower the melting point of cocoa butter. Very important point. Don't joke with this. Phenols and what? Chloral hydrates. They do what? Have a tendency to lower the melting point of what? Theobroma what? Oil or cocoa what? Butter. Hello? So these ones are soluble. So if you use cocoa butter to formulate them, these things are active ingredients. Coral hydrate is an active ingredient. If you use cocoa butter to formulate it, it will reduce the what? The melting point of what? Cocoa butter. It will reduce the melting point of what? cocoa butter. So, how do we take care of this? So, if there is nothing you can do again, that is, cocoa butter is what you want to use. Cocoa butter is a wonderful base. So that's why they keep telling you what you can do to help it. Hello? Cocoa butter is a good suppository base. Right? It's the most commonly used. That's why they are telling you what I want to add to help it achieve your purpose. Am I communicating? Now, here now, you add to make it, to take care of this problem. This reduction in the melting point by soluble active ingredient like phenol and chlorhydrate. To conquer it, you add solidifying agent. Example is what? Beeswax. 4% beeswax. 4% beeswax. 4% beeswax. Where do we add 2% aluminium stearate? We discussed yesterday. And what do you want to achieve with it? Where? Make what? Of what?
Cocoa butter.
Of what?
Una de agua.
Okay. All right, now. So if you add this solidifying agent, like what? 4% beeswax. If you incorporate it, it compensates the what? Softening effect of the added what? Substance. Am I communicating? Now, hey, another problem is rancidity. Another problem is what? Rancidity. Rancidity of what? Remember, the main reason why theobroma oil undergo polymorphism is high proportion of unsaturated triglyceride. And unsaturated triglyceride is prone to what? Oxidation. Hello? Is prone to what? Oxidation. That's why theobroma oil can easily go what? Rancid. Am I communicating? Remember what causes rancidity? We mentioned oxidation, right? Hydrolysis, right? What else do we mention? Okay. Now, so rancidity of what? Storage due to what? Oxidation of what? So what do you think we can do here to take care of this? What do you think we can do here? That means you try as much as, that means this will affect. One is that you should ensure that at least you protect it from air, from oxygen, air, and anything. Protect it with all what? By all what? Means. As in, protect it with everything you've got. And also, it will also affect, it will also affect the what? The shelf life. Do you think it may affect the shelf life? You may not need to stay long for a long time before you use it. Do you think it should affect it? Yeah, because maybe if others, the shelf life may be 2 years, for example, now you try to do what they may do, or shorten it also do what? Am I communicating? But the basic thing is to do what? Ensure that it's tightly what? Protected. In fact, do you think using in mold packaging and just ordinary what is it called again? Ordinary pour mold and using hand to do this and the package and put in mold. Do you think it's better? In package. In what? And apart from that, most of the extemporaneous formulation of suppository, they normally use what? Cocoa butter. Hello? Most of the extemporaneous normally use what? Cocoa butter. You know extemporaneous doesn't stay long. Highest what? 2 weeks, right? 1 month as a brain. All right. So how do we prevent softening of cocoa butter suppository? Huh? How? White beef. At what concentration? Softening or melting? Kosi. You just know, half percent. You never know. Imagine you possess. Or are you talking about softening point? Are you talking about melting? Which one are you talking about? Melting. Now, another problem is that you encounter is for leakage. Leakage from the water. So if you mistakenly maybe you didn't put it into consideration, adding what to make it to avoid this issue of what is it? Okay. If you mistakenly, anyway, what will cost you? Maybe it can happen if you mistakenly maybe you forgot or you don't even know that if you are formulating some drugs like chlorohydrate using suppository, using what is it called, cocoa butter, that you should add something that will not allow you to do what, melt what easily. Then you should be ready for the thing to melt, to leak, right? Or even if you forget that it gets softened easily. What makes it get softened? Why do you think it gets softened easily? Because of what? Now let's look at this. Leakage from the what? The body. Leakage from the what? The body. Leakage from the what? The body. So sometimes the melted base escape from the rectum. Hello? Sometimes the melted what? Base escape from the what? The rectum. Or where? Vagina. So it is rarely used as what? First way. It is rarely used as what? First way. It is rarely used as what? First way. Cocoa butter is commonly used as what? First way. True or false? Cocoa butter is commonly used as first way for first way formulation. True or false? Okay. Then, expensive is highly what? Is highly what? To compare with other, right? If you compare it with other, it's basically what? High what? Does it make sense? Does it really make sense? Yes. Now, one, two, three, four, five, six, 7. We discussed about 7 problems posed by what? Cocoa butter what? Suppository base. Question Akalia. Now, synthetic fat. Remember we talked about some. Remember I told you that when we are describing the what is it called? That benign specification for a suppository base, right? The first thing we mentioned was origin and what composition of the base should be known. So whether it is natural, whether it is synthetic, and whether it is so Cocoa butter is a synthetic fatty base. True or false?
It's natural.
Cocoa butter is a synthetic fat. True or false? Okay. Now, we use cocoa butter as an example for what? Natural, okay? Let's go to what? Synthetic. Let's go to what? Remember what I told you. Remember what I told you about the evolution in sciences. Most of these things that are synthesized, maybe natural one, maybe there's a particular purpose they want to achieve, and natural one is not giving them that particular purpose. They may look for a way to do, but see whether they can synthesize something else that is similar to that one, that can give a better word. Am I getting? It can be a reason for synthesizing some of these active ingredients. One. Secondly, it may not totally be a complete synthesis. It may be a semi-what? Synthesis. They may get a natural product and modify it to have an improved property. These are the reasons. One of the reasons why they do all this synthetic, whether complete synthesis or semi-synthesis. Now, let's look at synthetic fat. Now, in order to overcome the disadvantages of what? Theobroma oil. That's what leads to what? Synthetic substitutes. So they're searching for what? Synthetic what? Substitutes. So to overcome the disadvantages of theobroma oil, synthetic substitutes were what? Searched. So as we talk now, you go to most universities, some doctors, PhD holders, professors, even independent researchers that have their lab on their own are carrying out research in any field. Those in pharmaceutics, those in pharmaceutical chemistry, those in pharmacology, they are carrying out different research to be able to improve what? The life of what? Mankind. Am I communicating? So when they know that this one is not giving them what they need, more research started coming up. That's what leads to what? Synthetic what? Fat. Using what? Synthetic what? Fat. Now, how do we now obtain synthetic fat from this? Good. By what? Of vegetable oil, such as palm kernel and what? Arachis. Palm kernel and what? Arachis. Palm kernel and what? Arachis. Ude na class ay good kwa. Huh? Hello. In your organic chemistry, you did hydrogenation, right? Yes. So what is hydrogenation? Where? What actually happened in speak like a chemist, please. Don't get what you are in. Just speak like a chemist. Bring it down to chemical equation. What happened? What actually happened in hydrogenation? You did organic chemistry. Where did the hydrogen enter?
Into the unsaturated hydrogen.
Good. What are they what?
Hydrocarbon.
Which bond?
It's not maybe double or triple bond.
Single bond, okay.
No.
Why? Okay, all right. It's okay. Now, that's why the name is what? Remember what I told you. Remember. Each statement I make here, take it seriously, because I will still go back to it. Anything you see me here saying, still take it seriously. Make sure you understand, because I'm going back to it again. Remember, I'm saying this for a third time, what makes theobroma oil to be polymorphic is what? high level unsaturated. That means it can undergo any change. True or false? Now, only species that can accommodate. So, do you think hydrogenation can take place there? It can, right? But it is what? Unsaturated. Does it make sense? Does it make sense? Where did it stop? Speaker, where? Okay, why does tubular oil undergo polymorphism? So I'm asking them. You don't know. That is the origin of your problem. But we've been saying it here since now. It has high proportion of what? It has high proportion of what? It has high proportion of what? Unsaturated what? Right? Do you agree with me? What's on call there? Okay, I said, right. I said that the cocoa butter undergo polymorphism because of the high proportion of what? Unsaturated what? Right? That's the main reason. Now, we are not saying here now that I just wanted to point out something. That I asked them a question. What actually happens in what? Hydrogenation. What happens is that the hydrogen gets to the what? Bond, right? Good. And in hydrocarbon, examples of such bond is what? Double bond, triple bond, and blah blah. What it means that if you hear that a company is organic, whatever is unsaturated, which means that it's still open to what? More reaction. True or false? And they are reactive. True or false? Good. They can take in a lot. They can take in other things. So they are. I'm saying to come. Arcane is saturated or unsaturated? So what type of reaction does it? Substitution reaction, yes. It's not true. It's an substitution reaction because it is already what? Saturated. Bringing it to human relationship is taken, right? Hello? Somebody in the relationship is not taking, no. He's not taking. If you're not you are not taking, please, here, this new nonsense people should now. I am not saying. Hello? The point I'm trying to make is this: that our kids now that are saturated, they undergo substitution reaction. So that thing that blocked them must be removed before they can be free to do what? React. Mingle. Am I communicating? That will cause substitution reaction. But for the unsaturated one, the single one, as the case may be, bringing it to human relationship, those ones undergo addition reaction. There are many types of addition reaction. It can be hydrogenation. Hydrogenation is a type of what? Addition reaction. It can be halogenation. So many of them. But the point is that I'm trying to explain this hydrogenation. That's what is taking me to all these long stories I'm telling you here. So if at this level you don't understand it, I don't know how you understand it again. Now, that's why tubular oil now can actually undergo what? Can it? Do you think you can even though I may not say it, but use your common sense. Do you think you can actually subject to tubular oil to hydrogenation and get a semi-natural product? Can you? Okay, let's keep at that and keep going and see how it turns out. Now, so we know that these synthetic fats are obtained from hydrogenation and heat what? Treatment to vegetable what? oil, such as what? Palm kernel and what? Arachi. Now, listen carefully. Hydrogenation saturates unsaturated what? Glyceride. Very important point. Hydrogenation saturates unsaturated what? Glyceride. And heat treatment splits some of the triglycerides into fatty acid and partial ester, which are mono and di what? Glyceride. Listen carefully. Most synthetic fat bases are made, listen carefully, most synthetic fat bases are made by, first of all, hydrolyzing the vegetable oil, then hydrogenate the resulting fatty acid, then finally do what? Acidify the acid by heating with what? Glycerol. 3 steps. First step is what? Most synthetic fatty base. Most synthetic, but first of all, by what? Hydrolyzing what? Then what next? Last one is what? So 3 reactions. 3 reactions. Hydrolysis. Hydrogenation and what? Hey. Tell me the 3 reactions involved in the synthesis of fatty base. Stepwisely. Hydrolysis of what? Hydrogenation of what? Acid. If you hydrolyze with what will form? Then you do what? No, you do what? The first thing that happens is what? If you hydrolyze vegetable oil, what will form? Then you hydrogenate it, right? Then and do what again? With what? Okay, let's go. So why synthetic? What is the reason? What is the advantage? Why synthetic? Why synthetic? This is what I want to look at now. The advantages that made them to really go into this research to see how they can improve what. Number one is what? Are unaffected by what? Heating. Overheating, sorry. So their solidifying points are not what? By what? Overheating. I think it's an advantage, right? Unlike the Roman maybe issue. Now, number 2 is that they have good what? Resistant to what? Oxidation. Because their unsaturated fatty acids have been reduced. So, when is there any issue with what? Oxidation. What do you think rancidity? What do you think about rancidity? Good. So the tendency to go rancid may not be what? It may not even be there at all. Little or no tendency. Hello? So they have what? Good resistance to what? And why do they have good resistance to oxidation? Why do they have good resistance to oxidation? They are no longer what? Unsaturated. Hello? So that's the point. Then another one is this. The difference precious and nature, they did their own class. Their own class. Oh, Bob and the Miss Norma and Elizabeth, they did their own class. We did our own here. Hope people are following. Hope you're following. Please ask questions, please. Don't keep quiet if you're not following, please. What? They are the unsaturated fatty acids they contain, but they undergo oxidation easily. But in this synthetic one now, they are now reduced. So the tendency to be oxidized, they can resist oxidation. Is it clear? That's why they can resist what? Oxidation. Now, another point I want to make here is that the difference between the melting and setting point is what? Small. Generally, only 1.5 to what? 2 degrees Celsius. And seldom over what? 3 degrees Celsius. Hence, they set what? Quickly. And the risk of sedimentation is low. And they are easier to administer. So the risk of sedimentation is what? Low. Risk of sedimentation is what? Low. We describe this sedimentation, right, in this class. We describe what? Sedimentation in this class. So let's continue. Hello? All right. Let me ask a question. Let me take you back to chemistry. Let me take you back to what? Chemistry. You want to tell you that almost 80% of what you will be doing in pharmacy is what? Other basic sciences we share, biology, physics, we share other ones. 90% is what? Chemistry. Sorry, 70 to 80% is what? Chemistry. So if you have issues in chemistry, especially in the area of pharmaceutics and purely pharmaceutics and dispensing, chemistry is very important. It's vital. Now, in your chemistry, test for purity. In the test for purity in your chemistry, you were told, and I put it to you, that you were told that if there is an impurity in a liquid, and if there is an impurity in a solid, their boiling point and melting point respectively will be affected, right? So what happens to liquid if there is an impurity? What happens to the boiling point? What happens to its boiling point? It will do what? Increase. It will increase more than above the what? Normal. So the boiling point will increase. It will increase. Now, if there is an impurity in a solid, and you melt it, what happens to the melting point? The melting point will reduce than normal, less than normal one, normal melting point. Am I communicating? So we call it melting point what? Depression. And boiling point, elevation. Hello? Good. Isinye mmiri ọkụ na n'ọkụ. Isinye mmiri ọkụ ordinary water n'ọkụ. Wetakwa the same mmiri kpọkọnyecha ya ma ogiri okpeyi ma gudugudu. Here, two of them at the same time. Can you give the boil? So, the boiling point, and that one, if you pack things, will be higher than the water. That's what I'm making. Hello? Are we together? So now, remember when we mentioned chlorohydrate that is soluble in what? Theobroma oil. Remember? Chlorohydrate, if you put it in theobroma oil, it will do what? Depress the what? Melting point of what? Theobroma what? Oil. Because it is soluble in it, right? It will reduce the melting point of what? Theobroma oil. And this will affect the what? Suppository. True or false? Now, let's go back to this advantage now and see what we can make out of it. The melting point depression caused by fat-soluble drugs. Example, chlorohydrate, right? Phenols. Example of fat-soluble drugs, chlorohydrate and what? Phenols. In this case, another one, so that they're not the only ones. So the melting point depression caused by fat-soluble drugs can be counteracted by choosing a high melting point grade. A high melting point what? Grade. While the hardness and brittleness that sometimes results from a high content of insoluble powder can be prevented by using a low melting point what? Grade. You remember what I told you? Hello? In as much as, listen carefully, this natural one we issue, right? Now, but the synthetic one now, you can, because you have worked on it to produce something that will help you, it can come in different grades. Hello? You can now decide to produce it in what? Different what? Grades. You now have the ability to do that. True of us. Since you can modify the natural one, you can now fix a grade you want it to be, depending on the number of what you added, additives. We call it additives because there are additives you added to make it to live from natural to either semi-natural or synthetic, right? Now, for you have what it takes to now produce it in different what? Grades. We have high grades, we have low what? Grades, because you have worked on it. Hello? You have done what? Worked on it. Now, the grade you are going to use will now differ, depending on what is on ground. That's what we are trying to what? Point out here. For when you have fat-soluble, if we want to formulate a fat-soluble what? A fat-soluble what? Drugs like carbohydrate now, that the synthetic fat you are going to use should be of high what? Grade. That's the point I'm making here. It should be of what? High what? Grade. That's the point they are making here. Now, but if you want to checkmate brittleness, if you want to checkmate what? Brittleness. If that's what you want to checkmate, hardness and brittleness, you go for low grade what? Synthetic one, because they tend to have some level of plasticity, right? Right? To compare with what? High grade what? One, because high grade what is there to fight melting. True of us. While the low grade one at least can be a bit what? Plastic in nature, right? So if you want to fight against what? Brittleness and over hardness, you go for what? Low grade what? One. What the disadvantage is to say that you can choose anyone you want to choose, depending on what you want to achieve. But you know that cocoa butter on its own is not, you can't choose it because all your bokobo. But because you have modified it, you can choose depending on what you want to formulate. You can choose a high grade one, you can choose a low what, because you have modified it. Hello, are we together? That's the point disadvantage is trying to do what? Make. Now the next one is this. Now when it comes to tropical and subtropical areas, countries now, it's always advisable to formulate with high-grade synthetic what? Fat bases. Hello? High-grade synthetic what? Fat bases. When the what you are formulating is intended to be used in where or to be exported to tropical and subtropical what? Countries. Go for what? High-grade what? High-grade what? Synthetic what? Fat bases. Like Nigeria now, if you are producing in Nigeria, you don't need anyone to tell you to go for what? High-grade what? Synthetic. All right. See question. And if you get our side, you know that. What of those in the north? Huh? Canada. They can use low. They can use low. They can use low. They may even use natural ones. Yes, they may even use natural cocoa because that one has no issue. You know, major problem is what? Temperature, heat. This synthetic was was provided to fight against this what heat issues on the English. I don't know if I'm communicating. That so I believe that if you go through this, you understand it. Our time is almost. Okay, no, 9:30. We agree 9:30, right? Class, what do you have yesterday? I say what is it? What? You say 7:30 was 9:30. It's not 9. All right, let's continue. Hello, let's continue. Now, even though they have been reduced, the unsaturated distillate have been reduced. This synthetic one, they have what? They contain some proportion of what? Partial what? Glyceride. Hello? You can go up here. You're not following me. Almost a question. You say you have it. She wants to throw one bomb that will make me unstable. I don't answer. Let's continue. Let's continue. All right, now we are still discussing the what? Advantage. Or do you think you can understand the other ones?
No.
Should we jump to the disadvantages? Okay, we are almost through with the advantages. Let's complete it, please. So continue. They start from here. They usually
Okay.
Silence, please. Okay.
They usually contain a proportion of partial glyceride, some of which are glyceride monocytrates are W/O.
Well, what does W/O/O mean? I explained it yesterday. Water.
Water and oil modifying agents, and therefore their modifying agents and water absorbing capacity are good.
Is it modifying agent? Read that somewhere. Don't you see? They usually contain what?
Emulsifying agents, and therefore their emulsifying and water absorbing capacity are good.
So go read that one again. That one again. They usually contain what?
A proportion of partial glyceride.
Mm-hmm.
Some of which are example, glyceride monostearate
mm-hmm.
are water in oil, emulsifying agents, and therefore their emulsifying and water absorbing capacity are good.
Now that's the point, and in summary that the emulsifying capacity, emulsifying capacity and the water absorbing capacity of synthetic fats are what? Good. Hello, are we together? So what it means is this. Let's assume now, remember when we talk about incorporation of, talk about incorporation of water, right? Incorporation of water in the suppository base. Remember that we said that in fact that these things are incorporated as liquids. That you get the emulsion or get the what suspension of these drugs. Come. Victoria, come. Carry all your belongings and come. Come. Next one. Go.
Okay.
Sit here.
No more
No, sit here.
lubricant is needed because they contract significantly on cooling.
So they don't need what? Yeah. Because on their own they do what? Contract what? Significantly. Because volume contraction is also what? Enhanced. So there's no need for what? Lubricant. Are we together?
Yes.
Now, next one.
They produce suppositories that are white and almost odorless and have very attractive, clean and polished appearance.
That means there's high possibility of that these suppository you see, they are white, right?
Mm-hmm.
And very, very attractive, right? There's that high tendency that they use what? Synthetic fat as the what? The base. There's high tendency. So they are suppository for formulated using synthetic base are what? They are elegant, what? They have aesthetic value. That's the point I'm making here. They are clean, polished, and very what? Attractive. And they are almost what? Odorless. Hello, are we together?
Yes.
All right. You can go back. Victoria, come. Start from disadvantages.
Disadvantage. They should not be cooled in a refrigerator or ice because they become brittle if cooled quickly. Additives such as polysorbate aids to correct this fall.
Yes, very important. They should not be cooled in refrigerator. Do you remember? Can you remember when I was? Hello. Remember, when I was discussing these suppositories about putting in the refrigerator. I think I mentioned something like this. I said not all of them will do what? Someone asked that question. I don't know whether it's Elizabeth. I don't know who asked that question. It was like he was like, must we always put it in the refrigerator? I don't know who asked that question. I now say it depends on the base. I now say that it depends on the base. White Tiboroma oil, you must. Now they're telling you now that this for this synthetic fat base now, that you should not be cooled in what? Because they become what? Brittle. Eh? Are you serious? All right, let's continue, please.
Second disadvantage.
So, how do you correct this? You can add what? Polysorbate what? 80. Now, next one is what?
They are more fluid than theobroma oil when melted, and at this stage, sedimentation is greater. Thickness such as magnesium citrate, bentonite. Thickness such as magnesium citrate, bentonite reduces this problem.
Hello? We are saying here that they are more what? Fluid than what? Theobroma oil when what? Melted. Because of that, sedimentation may occur easily. Hello? So the best way is to take care of this is to do what? Add what? Thickness, like what?
Magnesium citrate.
Makamama Ajuge, this is an example of thickness. Child an example. Be playing now. Thickness like what? What is this? What's that? Yeah, now we are talking about disadvantages now. Huh? You say what? Synthetic that have been produced from natural one now. Remember we discussed the advantages. Now we are talking about the what? Disadvantages it may have. And what you can use to correct those disadvantages if you must use that base. Now if you must use that base, you have to factor in these things to conquer the what? Disadvantages. Yes, he said that they are more fluid. The fluidity, their fluidity is more than that of what? Theobroma oil when melted. So that means there is high tendency for what? Sedimentation to do what? Occur. So to take care of that one, well, when you say fluidity, that means that theobroma oil is thicker than them, right? Hope you know. Now, to take care of that one now, or take care of sedimentation, you add thickeners. There are 3 thickeners we mentioned here. You can add any of them: magnesium stearate, bentonite, and two. Magnesium stearate and what? Bentonite. These are examples of what? Thickeners. But I'm going to give you examples of thickeners. You see, naxizologia. I'm going to get you now. Continue.
The third one, the release and absorption of drugs in the body may differ for theobroma oil and synthetic bases.
Of course, now they do not have the same release pattern. Which one do you think should be better?
Natural one.
Okay, now if you are, let me not to phrase the question. It depends on what you are formulating. The one to use now, they do not have the same release pattern. The one to use now depends on what you are formulating and where you want to the target area you want to insert it. For example, now, if it comes to, let's assume now, if it comes to maybe rectum now, or maybe vagina, do you think which of them do you think will be more better for rectal and vagina? From what we have been doing since we started this class, let me hear your or let me say yes, let me say rectal and vagina, yes.
Synthetic one is better.
Rectal. Are you sure? Will it queer?
No, synthetic is better for vagina. Then natural rectal.
Rectal, right?
Yeah.
But you remember, you can add other things. Can you remember that? People are playing. Yes. Please, let's focus, please. Now we are done with what? Fatty what? Basis, right? Let's go to what? Hydrophilic what? Basis. Hydrophilic suppository basis. Continue. Continue. You're not going to have to continue.
1. Glycerin suppository. Glycerin 91 grams. Sodium stearate 4 grams. Purified water 5 grams to make approximately 100 grams.
Continue.
Number 2, glycerated gelatin suppositories. Drug and purified 10. Drug and purified water gelatin glycerin. 102.
Don't worry. This area you've not said you are dispensing practical. This is just formula. Formula for formulating. Am I communicating? Let me keep it on hold for now because let me just go down to what we have. This is what you do in your first semester 2. From all this formulation, this is just the formula. Now let's continue. Now, but I think I have exposed you to formula, right? When we did the powder calculation, right?
Yes.
But let's look at glycerogelatin basis. So that means, remember I told you that glycerogelatin base is what? And what type of base is that? Glycerogelatin base. What type of base is that? Hydrophilic what? Base. Good. Now, as I said before now, and as you can see here now, it's a mixture of what? Glycerol and what? Water. Into a stiff jelly By adding what? Gelatin. Hello? It should have a jelly-like consistency. Yes, the content is what? Glycerin and what? And what? And what? Sorry, glycerol and what? Water. But the consistency is not that of water. Hello? The consistency is not that of what? Water. The consistency should be that of what? Gel. And how to get that jelly consistency is to add what? Is to add what? Gelatin. Glycerol-gelatin base is a mixture of glycerol and water. Now the consistency I block that of what? Water. The consistency is that of what? Gel. Because of the addition of what? Gelatin. Note that point too. So what they use it for? Jellies, suppositories, pastries. Continue.
And its proportion is changed according to its intended purpose.
Good, a very important point. In as much as it contains water, glycerol, and gelatin. Three of them are present. Their proportion can be changed depending on what you want to do, achieve. Now let me ask a question. Since you can use this for jellies, suppository, and pastry. Now, if you want to use it for jellies, in their proportion, what do you think should have the highest proportion? Gel, like what of suppository? You say? You say? Now, what of okay, listen carefully. Remember, I told you something. Hello. We are going back to what I told you in the beginning of this class.
Glycerol-gelatin dissolves in body secretions and therefore is preferable to a fatty base for administering antiseptics.
Hello. It dissolves in what? Body secretion.
And therefore is preferable to a fatty base for administering antiseptics.
Good. Are we together? It dissolves in what?
Body secretion.
Therefore, it's preferable to a fatty base for administering what? Antiseptics. Are we together?
Yeah.
Now, do you think? Okay, let's look at. Do you think this and fatty base? Which of them do you think should be better for pastry?
This one. This one is better for pastry. Fatty base.
I think glycerol-gelatin base and the fatty base, which one is preferable for pastries? Why? In where? Melt what? Good, because they dissolve in body what? Secretion. Hello? Hello? Is it clear? So let's continue. Continue now.
Since solution is slow, drug release is more prolonged than for fatty base.
Solution is what? Slow. Hope you know that melting and dissolution, can you get it faster? Dissolution. But you know, after melting, the active ingredient will just partition. Bam. But this one, after dissolving, dissolution, the active ingredient will need to seep out. Seeping out from the formulation is a slow process. It's not a fast process. In dissolution, seeping out from you know what I mean by seeping now? Seeping out from the dissolved or disintegrated formulation is slower, is slow down. But when it melts, once it melts, you can easily do what? Partition and go its way. Is it clear? So that's why they said here that because solution is slowed, drug release is more what? Prolonged than what? From fatty base. So constant, steadily, it will be gradually releasing for over a long period of what? Time. Than for what? Than when using what? Fatty base. Am I communicating? So the content. So that means what's the implication of this? That means for a local action, maybe treatment of vaginal infection, locally, it can easily be releasing actually just in a continuous, steady, and slow, prolonged pattern. So there will be contact with the microorganisms will be what? More. True or false? To compare with what? Fatty what? Base. So as you can see, if you look at that, what we have, you see a flow chart there on how to prepare what? Glycerol-gelatin base. First of all, remember I told you it contains 3 components, right? Glycerol, water, and what? Gelatin. Simple. So what do you think can be a disadvantage of this glycerol-gelatin base? Close that material, use your brain and think out something. What do you think can be a disadvantage based on what we've been discussing?
There will be hygroscopic.
They are what? More? How?
Yeah, hygroscopic. This is critical. Like the one and
Okay, now let's continue. Hello.
Hi.
What's time?
9:20.
After this disadvantage, you stop, please. Read up. 9:30. Read up. Yeah. Read it for us.
They have physiological action. That they are used as laxatives.
Wait, to Jello. Meaning what? What type of? They have advantage. They have physiologic action. If that means continue from the second line, please.
They are more difficult to prepare and handle.
Yes, I agree. That is yes, the other advantage. Continue.
Their solution time depends on the content and quality.
No, because they are difficult to watch. You see that formula? You see that formula there? That formula you use to even prepare it first before you start the main work. That formula, that formula you saw before. That formula used to prepare the base before you start the main preparation. So, and this issue of trying to balance the proportion, get the proportion of each of them is not an easy thing. Okay, because if you make mistake, this one is more than the proportion it should be. You have messed up everything you are doing. That's the difficulty that they are talking about here. All right, continue.
Their solution time depends on the content and quality, and gelatin and the age of the base.
Their what again?
Their solution time depends on the content, the quality, the gelatin, and the age of the base.
Their solution time, that is the time for the what? Remember, we talk about, anytime we hear solution, you are talking about dissolution, okay?
Yes.
I hope you know. It depends on a lot of things. So that means any of the 3 of them have issue, the whole thing is what? We messed up. If you get it, it's a wonderful thing, but if you don't get it, I'm sorry for you. That's the problem with it, okay? So continue.
They are hygroscopic, so a careful storage is required. It also leads to dehydration of the rectal mucosa with consequent irritation. This is an advantage where a laxative effect is required.
I'm not sure why that laxative whatever should be an advantage, okay? Now there's a point here. They say that they have what? They are what? So they can absorb So in a book they can dry off the what? The what? Rectum. Because they do what? Apart from the storage issue, they will absorb moisture and start having issues, even though they will not dissolve. When they are used as suppository, the suppository may be busy what? Absorbing the what? The rectal what? Fluid, right? That's the point we are trying to make here. This is what this leads to the dehydration of the rectal mucosa with consequent what? Irritation. This is an advantage where laxative irritation. What is the relation between bowel movement and laxative? Do you think bowel movement helps laxative? What does laxative do? So if there's a bowel movement, will it help to constipation or will it stop constipation? If there's bowel movement, what is the effect in constipation? Huh? What is constipation? So, if you are having bowel movement, can you defecate easily? Bowel movement. So if you have proper bowel movement, you can take the laxative and bowel movement. What the relationship is between them? They improve what? Do they improve bowel movement? Yes. Now that's why they said here that these suppositories, because they're hygroscopic, they can dry off. They can dry the what? They can cause the dehydration of the rectal mucosa and cause irritation. If there is an irritation in the rectal mucosa, what will happen? Bowel movement will take place, right? Even though the bowel movement will not help other suppositories to be absorbed, but for laxatives, it will help them. That's what they're saying here. Is it clear? That's what they said. They said it also leads to dehydration of the rectal mucosa with consequent irritation. This is an advantage where laxative effect is what? Required. Because irritation will cause bowel movement. And bowel movement will do what? Tackle what? Constipation. Because even when no bowel movement, you can do what? You say to after again, a pour by force. So I wish you people luck in your exam. So please study. Study suppository 67 questions. 67 questions. Tablets, powders and granules, tablet and capsule. 3 questions will come from there. So please study.